So to begin, we're going to build the context that underlies everything else that we're going to learn in this course. If we want to take a deep dive into any programming language, concept, or technology, we need to understand a couple of things first. Mainly, we need to understand what is it that computers do. What makes a computer a computer? Where is that defining line that makes you say that something is a computer? So to start off this course, we're going to look at something that I like to call the information problem, which is really the why behind software engineering and information technology. We're going to look at this problem because the entirety of, writing code, programming, coding, whatever you want to call it, it really involves just solving problems that have to do with information in some way or another. And understanding this perspective is extremely crucial because it will make a difference when it comes to all the different applications and programs that you will ever build in your career. It's this perspective that will drive your understanding of all of the components that are involved in a particular problem that you need to solve, as well as how these components interact with each other and why you need programs or software to solve the problem. That way, you can feel very confident when applying your critical thinking needed to actually write code to solve these problems. The other thing it'll do is it'll prevent you from running into something that, countless people that I know run into, where, you learn a particular language or, you learn how to write a web page or you learn JavaScript, for example, but you don't learn anything beyond that, or there's no supporting context showing you why it is you're able to do what you're doing. And so you run into the problem where, people say, I know how to write in JavaScript, but I don't know what to do with it. So we really want to avoid that. Once we understand the information problem, then we'll move on to actually building a computer. And you will see how it only takes a few number of key parts to actually solve an information problem and actually define what a computer is. And I bet after that you will be surprised as to what actually makes a computer, a computer. As a final note, there isn't much required knowledge or past understanding for this course. You don't need any software or science or maths background or anything really. If you can just understand that, what electricity is and that it needs wires and conductive materials to flow, then you're good to go. Other notes is finally, while this section doesn't involve any code per se, don't worry, we will be writing plenty of code throughout this course. However, trust me, it's going to really open your eyes about the world of computers, and you'll probably only really be able to fully appreciate this in a couple of lectures further down the course. So let's get started. So what is the information problem? Well, it starts with a 1 million year old story about humanity. When we compare a human to the rest of the animal kingdom, from an organism point of view, humans are actually quite mediocre creatures with unimpressive physical abilities. We're not fast runners, we're not very strong, we are embarrassingly slow swimmers, and overall just don't match up. What this means is at an individual level, we stand little chance when up against a common predator. But humans are at the top of the food chain. So what happened? What happened was humans developed an ability to use our minds. Over time, we developed multiple parts of the brain that were much more advanced than in other organisms. And this allowed us the ability to store core units of information and combine them in multiple ways to model a certain world around us with rules and norms to follow. And this allowed us to understand and articulate very complex things that were much more intricate than what other animals could do. What this did at the end of the day was give us an ability to coordinate in massive numbers over very wide areas. And this allowed us to harness the powers around us that would otherwise be inaccessible to a single individual. The situation is now one where we have billions of people working together to design, plan, and improve the comforting society that we live in today. We are where we are because our brain solved what I like to call the information problem. The information problem refers to the foundational abilities of a human brain. It first involves a core layer, related to a single human brain's capabilities. This is where a person can create, store, retrieve, edit, and delete information. For example, when you pour a glass of water and you put it on the table, you've effectively created new information that there is a glass of water on that table. Say now your friend calls you or you get distracted, so you need to store that information that that glass of water is still on the table. Now when you get back to thinking about what you were doing, you can now retrieve the thought and remember that you had that glass of water on the table. Say now you drink the water and put the empty glass on the table. You have effectively edited the information to the glass now being empty. And finally, when you put the glass in the dishwasher or put it away, the status of the glass is no longer of any use to you, so you go ahead and delete that information and forget about it. Outside of this core layer is a second layer called an enhanced layer. And this relates to things involving multiple brains or people interacting with each other, as well as in the wider society and ecosystem. It deals mainly with being able to share, receive, and act on information in an appropriate manner. The enhanced layer, as you can maybe tell from this diagram, cannot exist without the core layer. For example, two people can only communicate with each other if they use the core layer to build the information needed in the first place. Understanding this is very important because the objective of software is all about harnessing these same information capabilities as a brain, basically putting this into something else. And in the last couple of decades, scientific advancements have allowed software to do so at incredible speeds and scales that surpass our own minds by many, many orders of magnitude. It's become such a powerful tool that we now cannot live without software. Solving the information problem is all we need to be able to, for example, watch a YouTube video online, or for a news channel to report breaking news and broadcast it to its viewers on TV, or help businesses react immediately to customers who are complaining over the phone. It is these possibilities through which software adds value to us, and is also why this domain is called information technology. The other important thing to understand about software is that underneath it all is a real physical process that's unfolding. This physical process mainly involves electricity running through wires, electromagnetic waves soaring through the air, as well as the metals and materials needed to make it happen. Specifically, all software really does is get electricity flowing in the right places at the right time, so that that pattern of electricity represents some type of information that's applicable to whatever is using it. Don't worry too much about this, we'll understand what we mean in the next couple of videos. Now you might still be thinking, I just want to code, honestly. Well, I'm telling you that you need to realize that software is just a tool used to solve information problems. And this is crucial to developing an empowering mental model around all the code that you will ever write. It's this mental model that will help you look at any problem and know the key aspects behind the issue, what to do to go about solving it, as well as what you need to learn or figure out in order to continue on. This chapter is also important because in successful tech companies that have good processes, building a software project or feature involves first writing a high-level plan of the objective and what information problems need to be solved in order to reach it. Only later do you really write and optimize the software that you need to solve it. So really, you should never try to think in code or frame your thoughts in code if you really don't know what you're trying to do in the first place. In reality, you will realize that programming involves problem solving more than anything else. The truth is that writing software is part of a wider problem solving process that starts with being able to comprehend the problem, understand what is going on that is causing this issue in the first place that you have. You then need to be able to represent the problem in formal terms and nuances that are applicable specifically to your team, your industry, and whatnot. And then you go ahead and plan a solution that would mitigate that problem and reach your objective. Only then, once you're done that, do you actually go ahead and execute your plan, and this is where you write code. This is where you program. Once you're done executing the plan and you've written your program, then you go ahead and interpret and evaluate your solution. Is your code doing what you need it to do? Is it doing so in a consistent manner that you can rely upon? And how do you know that's the case? And then probably you'll go back to finding another problem to solve and starting the cycle all over again. And this is what pretty much software engineers do in companies. So if you notice, the programming is only actually a small part of the overall work. I mean, you will spend many hours programming in each of these problems, but you notice it's still just a small piece in the overall problem-solving puzzle. And understanding this will literally change your life. So the development of this mental model is indeed the focus of this chapter, after which I hope you will have a more mature way of thinking towards the software that you will write. This is something that if you don't teach explicitly, it can take many months, even years of programming and mistakes to understand. Which in and of its own isn't a bad way to go about learning things, but I hope to give you a more seamless and thorough experience. So throughout this course, we will keep this in mind and employ these principles throughout the tasks that we will complete so that we can understand how to apply and improve this mindset all the way up until to the point that you can do it all on your own. And that's where you become a true independent, motivated self-starter when it comes to software. And some final takeaways of this chapter is that firstly, we'll understand the idea that all software really just builds on other software. And this ultimately just boils down to the same core sets of foundational capabilities that a computer can do. This chapter and the next are easily the most boring chapters in this course, where you will indeed code the least. But they will provide you with the invaluable ability to think critically right off the bat about the code that you will write in these later chapters. And after going through this chapter, you will be able to feel like you are grabbing hold of the computer as you code, and that you really understand what makes it possible for any kind of code to run. And that's also because you will be able to tie the code to what is actually going on underneath physically in the computer. And finally, because once you do know what makes programming in Python possible, for example, you'll be able to go off on your own and apply this understanding towards anything else, say installing and learning any other language or technology that you see fit. And that's because you will know what you do know what you don't know, and know what you do need to know, and how to go about learning that. So as we go along this chapter, the components of the information problem and the mindset needed for all this will become clear. Now we can continue on with looking at the building blocks that will form your foundation of problem solving in the domain of information, and that's hardware.